Now, let's try to analyze this displacement time graph here. Okay, so let's say you are given this displacement time graph and you want to change it into the actual motion that is happening. So graph is not the best way to think about how the motion is happening, right? So graph is an accurate way of representing how the things move, but it's not the most intuitive way of thinking how things move. So this is how I change the graph into something more intuitive for me to think what is happening. Okay, again, what I do is I bring back my lines and my dots. Okay, you don't it's not a must do it this way, but this is how I think about it. Okay, so let's analyze this graph portion by portion. Let's start with the first portion here. Okay, so what I do is I pull up lines with an equal time interval. Okay, from 0 to 1 and 1 to 2, these are equal time intervals. So I pull up the dotted lines, touch the displacement time graph line here over here. Then I pull it to the y-axis. So when I pull it to the y-axis, I can see that the distance traveled as time passed by increases. Before that, in 1 second, I'm only able to travel by this much. But for the second, from time equals to 1 to time equals to 2, the second, I can see that the distance traveled is increased compared to the first second over here. So if the distance traveled increase for every second that has passed, that means the velocity increases. Okay, it's in the same direction, so the magnitude of the velocity increases, so the velocity increases. So what I can say here is it's speeding up, or the magnitude of velocity increases, or we can say the velocity is increasing. So in that case, we know that the shape for a graph, for displacement time graph, where the object is speeding up, should be looking like this. So for increasing speed, our graph should be looking something like this, curving upwards. So if we see a displacement time graph that curve upwards, we know that the speed is increasing. Okay, so now let's move on to the second section. Let's focus on this part of the journey here. Okay, this part of the journey, again, I draw lines to for every second that has passed. So here 3 to 4, 4 to 5, 5 to 6, all of them are equal interval. So I draw lines of equal interval on the x-axis, then I bring it to the y-axis. So when I bring it to the y-axis, I notice that the distance traveled for every second that has passed from 3 to 4, let's say from 2 to 3, the distance traveled is this much. From 3 to 4, the distance traveled is also this much. From 4 to 5, the distance traveled is also this much. From 5 to 6, the distance traveled is also this much. So you see that the distance traveled for every second that has passed is the same. Okay, I travel the same amount of distance for every second that has passed in between the second and the 6th second. So from here I can see that the distance traveled is the same, so the speed is remaining the same. So I can say that this portion of the journey is moving with constant speed. Okay, so if I notice a displacement time graph with a straight line like this, I can immediately know that this is a graph which the motion is in constant speed. If an object is moving in constant speed, the graph should be a straight line, not curving upwards or downwards, just a straight line. Then you know that it's constant speed. Okay, the last section here is from here to here. So we know that this is not a straight line, it's curving downwards, curving this way. Okay, so again we draw lines of equal time interval, then bring it to the y-axis. Then we see that the distance traveled decreases. Initially from the 6 to 7 second, you travel a certain quite a big distance, but from the 7 to the 8 second, you travel a lesser amount of distance. So that means the distance traveled for every second that has passed is decreasing with time. So in that case, we know that this portion of the journey here is slowing down. So from here, we can make a conclusion. If the object is having decreasing speed, the graph should look something like this. Something like this. Okay, so this is how so if we see a graph that curves upwards, we know it's increasing speed. We see a graph that is straight line, we know it's constant speed. If we see a graph that is curving like this, curving to a flat, something like this, that is decreasing speed. Okay, all this discussion here is happening for displacement time graph, okay? Not velocity time graph, not acceleration time graph, displacement time graph. So that's how we try to understand a displacement time graph. So once you get familiar with how displacement time graph works, you can straight away see that this portion is speeding up, this portion is constant speed, this portion here is slowing down. Okay, you get used to it as you practice more and more.